Using the method of Gauss' law, determine the electric field at a point that is 3 meters from an infinitely long rod of charge. The rod has a linear charge density of 6 coulombs per meter. So, getting started with this problem, we want to draw our rod. So we have a rod right here. Now we need to figure out what Gaussian shape will follow the electric field of this rod. And it turns out that a cylinder is a shape that follows the field of a rod very well. Why a cylinder? It's because when we have a point, you know how the electric field always go out radially? So if you have a rod, it's going to go out from top to bottom too, but it's gonna go outwards this way as well. And do you see how this is very similar to a cylinder? Because of this, we could use this cylinder as our Gaussian shape. Okay, moving on. Now, what else can we recognize? We can recognize that there's going to be 3 points, 1, 2, and 3. Okay. It says here electric field at a point that is 3 meters. So 3 meters here. We have electric field here. And we have a surface area here, vector here. And for this point, we have electric field here. We have a surface area vector here. And for this point, we have electric field here, surface area vector here. All right. So our top and bottom points is when our E vector is perpendicular to our surface area vector. So let's write that down. So point number 1 and point number 2 is when E is perpendicular, which we can also say it is tangent, because perpendicular and tangent are used unanimously. Therefore, if we remember our equation to find phi, which means flux, phi is flux, it's going to be the integral of E times dA. But then because E is tangent to dA, you're going to multiply it by cosine 90. And cosine 90, we know that it is 0. So 0 times anything is 0. Therefore, the flux for these 2 points is going to be 0. Now, second thing that we can recognize is that E here, point 3, E, is parallel to dA. So point 3 is when E is parallel to dA, which I don't have to write to dA because it is just to keep it consistent with this. Therefore, phi for flux is going to be equal E times dA. But instead of cosine 90, because this is for tangent, it's going to be cosine 0. Which cosine 0 is 1. Therefore, it's going to be the same thing as saying we're trying to find the charge inside over epsilon naught, because it's basically just the surface area times the electric field. Okay. And epsilon naught is just a constant, electric constant. So with this, we could simplify this. We could pull E out. Flux is going to be equal to E out times the integral of dA. Cosine goes away because it's just 1. Anything times 1 is itself, okay? Equal to Q inside over epsilon naught. Okay, now looking at this shape, we have a cylinder here. So we could substitute the integral of dA because in mathematics, integral is area under the curve. So it's just going to be the area of this surface area. So it would be the same thing as E times surface area of a cylinder, 2 pi r h equals Q inside over epsilon naught. Okay, now E is still not isolated, so we have to isolate E. So in order to do that, we divide everything. We divide both sides by 2 pi RH. 2 pi RH. And dividing a fraction, because this is a fraction, Q inside over epsilon naught is a fraction. Dividing by a fraction is the same as multiplying by the reciprocal. So it would be Q inside epsilon naught multiplied by the reciprocal of 2 pi RH. So it would be 1 over 2 pi RH. Okay? Now, before we move on, let me erase all of this to create more space. Okay. Now that we have more space, we can continue. So next up, we need to recall that we need to simplify this. Before that, recall that KE is equal to 1 over 4 pi epsilon naught, okay? So we want to integrate this KE into this equation somehow. But here's the thing. Here we have 2 pi and we have epsilon naught. But here we have 4 pi epsilon naught. So we need to turn this 4 pi into 2 pi. And in order to do that, we multiply 2 on both sides. So it will be 2KE is equal to 2 over 4 pi epsilon naught. 2 over 4 is the same thing as 1 over 2. So it will be 2KE is equal to 1 over 2 pi epsilon naught. So you see how this is similar to this now? Now we're making life easy because Q inside 2KE times 2 pi epsilon naught, because if you divide 2 pi epsilon naught on both sides, you get 1, right? So that over 2 pi RH and epsilon naught over here. Epsilon naught. With that, you see how this is the same thing as this, but with this added. We can cross 2 pi out, cross 2 pi out, cross epsilon naught out, cross epsilon naught out. You have E is equal to Q inside 2KE over R times H. Radius times height. Okay, now here's our next mission. We want to know what the charge inside is. So let me erase this part to have more space. Charge inside. With this cylinder, charge inside, we know that, okay, first of all, the charge density, the rod has a charge density of 6 coulombs per meter, okay? Now, the charge inside is going to be the height of this cylinder multiplied by the linear charge density. And we need to recall the formula for linear charge density. The formula for linear charge density is going to be this lambda equal to Q charge over L, which is the length. Okay, so charge inside is going to be the height multiplied by a linear charge density, which is this. So multiplied by lambda. Okay. So now that we know what Q inside is, circle that because this is crucial information. We can plug it in for Q inside here. Therefore, let me erase this part to create more space. E is going to be equal to Q inside, which is height times lambda, 2ke over radius times height. Now, right off the bat, looking at this, you could cancel out the height. So you should get E is equal to lambda 2ke over the radius. Okay. And now is where the fun begins, because we can just plug and chug at this point. So we know from the problem that our lambda, linear charge density, is 6. So we plug 6 in, times 2 times ke over the radius, which it says here that the point is 3 meters from an infinitely long rod. Therefore, the radius is going to be 3 meters. So 3 right here. With that, we could just bring out our calculator, plug in the numbers, which we could do arithmetic. It's 12 over 3, which is 3, 6, 9, 12. It's going to be 4ke. But just to be sure, we do 6 over 12. That is not 12. 6 over, no, 12. 6 times 2 over 3. Okay, we get 4. So E is equal to 4 ke, and our unit is going to be newtons per coulomb. So this is our answer.